So pandas are indeed beautiful creatures that are native to China. However, if you decided to go on a day out with a bunch of pencordians and you said, I love pandas, I can guarantee you that at least Mike would turn around and say, yes, isn't it a wonderful Python library? So you can always judge the level of geekiness when somebody says pandas in terms of how they respond. So Pandas is a wonderful open source Python library that basically provides powerful data structures and analytical tools. So whereas NumPy was really good for dealing with multi-dimensional arrays, and we've seen examples of where that might be useful, Pandas is very powerful for manipulating data in large arrays and allowing for indexing of that data. And we typically use both NumPy and Pandas together. We use NumPy to do the advanced mathematical functions applied to this big data, and Pandas used to manipulate the data in some way. So they very much go hand in hand. And as with NumPy, as I mentioned earlier, when you import it, there's a convention that you import it with a traditional alias, and the alias for pandas is PD. So we should always write import pandas as PD and then refer to pandas as PD throughout the rest of our code. So one of the most useful structures in pandas is something known as the pandas DataFrame. Now, this is part of the reason why I think pandas is a little easier to get your head around, because a data frame is basically like a table with different columns which have different names representing different data fields, and then you've got different rows for each entry in the data. And that's something that we're all much more familiar with. You think of a table in Excel or a table in a database. So it's much more like that, only far, far more powerful. And again, like NumPy, with the potential to have more than 2 dimensions. So we can have multi-dimensional array data frames beyond 2 dimensions, which are much harder to deal with. So again, Pandas has that wonderful way in which it's far more efficient to deal with that kind of structure. So here's an example of something we might put into a data frame. We may have a table essentially that has a patient ID, a patient's name, their age, and their location. So how do we create a data frame? So let's have a look at how we create a new empty one, and then set up some lists of data that we can then add into the data frame. So the first thing, always, we must import pandas as PD. And then I'm going to set up a new data frame here, and I've just called mine DF for data frame. You can call it whatever you like. But it's always I always tend to use DF somewhere in the name so I can easily see at a glance that it's a data frame. And the way we set it up is just by saying pd.dataframe, and that will create a brand new empty pandas data frame. So then what I'm going to do is I'm going to set up some lists, and these are the lists I'm going to add into my data frame. So I may have a list of patient IDs, 1, 2, and 3, list of names, Bob Rogers, Fred Miles, and Janet Smith, list of ages, and a list of locations. Now we've got those lists, we can really simply add them into our data frame. And the way we do that is we give the name of the data frame, and then as the index of that data frame, we give the name of the column. Now, if that name of the column doesn't yet exist, it will create that column name. So at the moment, when we first set up the data frame, it's just an empty data frame, doesn't contain anything at all. So what we can do is we can say, okay, we want a column called patient ID, and I want you to populate that column with the list of patient IDs that I've set up here. Similarly, I want a column called name, and we're going to set that up using the list of names, same with age, and same with location. So these statements will set up these new columns. So we'll have 4 columns in our data frame. Each one will have a name, so we can refer to that name. And then we've got some initial values to put into our data frame, which are populated from the lists we set up here. So if we then to print the data frame to see what it looks like, using the print command, you would see it would look like this. So it would have our patient IDs, it would have our names, our ages, and locations. Fantastic. However, you'll also notice if you do that, you've got a mysterious 5th column here at the very start. Now that column gets added automatically by Pandas, and it's known as the index column. And it's because Pandas, like, and if anybody's used databases before, they'll be familiar with this, Pandas data frames need unique identifiers for each entry, so that by giving that index, we can ascertain the exact record, the exact row that we're talking about. So by default, Pandas will put in an index column for you, and it'll just start, as you can see there, counting from 0, and then each new entry, it'll just add 1 to that. And that might be absolutely fine. However, in many cases, you will find that you already have a unique identifier in your data. So for example, patient ID should be a unique identifier for a patient. And so if we've got a unique identifier in our data already, rather than having the separate index, we can simply tell Pandas to use one of our fields as our unique identifier, as the index value. So let's see how we can do that. So let's see, in this case, we decided patient ID is unique and will uniquely identify any of our patients. So we want that set up as the index. So all we have to do is use the name of the data frame, which remember I called df, and I'm going to run the set index function of that data frame. And I pass to that 2 arguments. The first argument is the name of the column that I want to set as the index, in this case, patient ID. That's the column that I want to now be my index. And then the second one, I've got in place equals true. Now, that just tells Pandas that rather than creating a brand new data frame where patient ID is the index, I want you to change this in place. In other words, change the data frame itself. Don't create a new copy of it. Change that data frame as it is. So in place equals true means change the data frame as it is, so that the index is now set to patient ID. Don't create a new one. And then if I print that data frame, you'll see now we don't have that mysterious 5th column, and instead we've now got patient ID representing our index. So we can now use the patient ID to refer to our particular patients. Now we've got that set up, what we can also do is to retrieve certain records using our index, using the lock method, which stands for locate. So all we do is we use the name of the data frame, and we call the lock command on that on the lock function on that data frame, and we specify the index or indices that we want to retrieve. So if, for example, I say df.lock2, that will now, because we've got it set up so that the patient ID is now the index, it'll retrieve me the entry with the corresponding index or patient ID of 2. And so if I print that, it'll print me this information here. It'll say the name is Fred Miles, the age is 31, location is Truro, which is what we see here. But as well as just retrieving one entry, I can actually retrieve multiple entries all at once. So it might be, for example, that I want to retrieve patient records for patient IDs 2 and 3. And so I can, again, use the lock function. And instead of just passing a single value, I'm going to pass a list of values. So note the double square brackets. The outer square brackets are saying this is the index. And then the inner square brackets are saying, and the index is a list of indices. So here I'm saying, give me 2 and 3. And so if I would print that, you'll see it provides me with both patients 2 and 3, both Fred Miles and Janet Smith. I can also do that using a slice. So rather than listing out all of the individual entries that I want, I can say, give me all patient records with patient IDs between 1 and 3. And so I can use the slice notation, which you're starting to get familiar with now, using the colon by saying 1 to 3. Now note, this isn't a list, it's a slice. And so there's only a single square brackets that represents the index value itself, 1 to 3. And if I do that, you'll see it returns all 3 patient values there. We can also, as well as retrieving specific rows, specific entries, records within our data frame, we can easily grab certain columns. So let's say we wanted to grab all the names in our data frame. Now what we can do with that is simply use, we don't have to use the lock command. We simply say df and then open our square brackets and then just simply give the name of the column that we want returned. So in this case, I want the column name. And if I do that, and if I print that, you'll see it return the list of names in our data frame. You'll also note that the index column is automatically included in that output as well, which in this case we've set to patient ID. So let's say we wanted to add more records, more rows to our data frame. Now, it turns out the most efficient way to do that is, and I know this sounds counterintuitive, but I've checked it out and this is the case, is to declare a new data frame which contains the new rows we want to include. And then we use the append method to join the old data frame to the new one. What we do is we use a dictionary which establishes the new values associated with each column. So in our original value, in our original data frame, we've got patient ID, name, age, and location. So I'm going to set up a new data frame here called data frame, I've just called it df2, equals pd.dataframe to set up a new data frame. But rather than just setting up blank, this time I'm going to specify right in that initial statement what that data frame is. And I use curly brackets here to indicate this is a dictionary. And I give this as a dictionary where each index in that dictionary represents the name of the column. And the values associated with each index represent the list of values that I want to add to that column. So here, let's say I want to add patients 4 and 5, as we've got over here, Lucy and Dave. So over here, I want to add patient IDs 4 and 5, names of Lucy Rivers and Dave Jones, ages 28 and 61, and locations Plymouth and Plymouth. So I've put all that into a dictionary within the data frame call, and then I need to also make sure that the index is the same. If I'm going to join them together, I need to make sure that the index is the same on this new data frame. So remember, in our original data frame, we set patient ID to be the index. We need to make sure we do that in our new data frame before we join it too. So here, I'm going to say, call the set index function again, exactly as we did before, this time on our new data frame, df2, and again, put it on patient ID, and again, we want it changed in place. And then once I've got that, I've got 2 data frames now that I can now join together. So the way I do that is I want it to, in this case, to overwrite df. So I want df now to be the new data frame that contains both the old data frame and the new one. So I say df equals df.append, and then all I pass into append is the new data frame, df2. And then if I print df, df now contains the first 3 values that we had before, as well as the new entries, the new records that I included here by specifying them in a dictionary. So it's a little bit fiddly, but if you remember that essentially you're setting up the new data frame and you're passing in the values you want as a dictionary, you can do that quite easily. Fortunately, it's even easier if you just want to add a column. So rather than adding more records, let's just say we want to add another column to our data frame. All we need to do for that is to set up a list of values that we want to add for our new column, and then simply add that list as a new column to the data frame. So let's say I want to add in a new piece of data into my data frame, which indicates whether they were previously admitted. So I'm going to set up a list called list of previous admission. And let's say that those have values true, true, false, false, and false for the patients 1 to 5. And then all I need to do is to then reference this new column. Remember, if I refer to a column that isn't created yet, it will create it. So I'm going to say, give me the previously admitted column, which doesn't yet exist. And in that, I want you to bung this list. And so then if I print the data frame, it'll have added these new values. So each record will then have the corresponding new value. Now, in case you're worrying, and thinking, does this mean that if I've got a data set of 100,000 patient records, I'm going to have to type all this in? No, you're absolutely not going to do that. And as I say, as we go on, you'll see that there are methods to easily read in your data directly into a Pandas DataFrame. Nonetheless, it's very useful to know how you will add various records and add extra columns in, because it might be, for example, that you want to add in another column that's only going to be important for your program, and so you can do that in this way. Okay, so that was Pandas in a nutshell. So what I want you to do now is to have a practice on playing with pandas. So you've been given a table containing data on minor injury units, and that's this table here. So in the table, you've got a minor injury unit number, which is a unique identifier for that minor injury unit, the location of that minor injury unit, whether it has X-ray facilities or not, and the opening time, whether it's a morning, afternoon, or evening MIU. And what I want you to do is write a program that stores the 4 columns in that table as separate lists. And as I say, please don't worry, you wouldn't have to do this in the real world in terms of putting in all your data from scratch. Then you're going to create a new Pandas data frame that contains this data in named columns, and you're going to set MIU number as the index. We're going to imagine that's a unique identifier for each MIU. I then want you to get the program to print out the data for MIU numbers 571 and 732. That's the ones in St Austell and Lou. I then want you to get it to print out the location column of the data. I then want you to get it to add a new column that stores the mean number of patients seen per day, which are 4, 3, 3, 1, and 2 respectively, and then print the new data frame. So you're adding in an extra column here, and that indicates the number of patients they see per day. So Lostwithiel sees 4, St Austell 3, Truro 3, Lou sees 1, and Camborne sees 2. And then to add a new row representing the data for minor injury unit number 901, which is a morning MIU with X-ray facilities in Callington, that sees 5 patients per day, and then print out again your new data frame. So I'm going to give you 30 minutes to do that, so you can have till 4:10. Again, feel free to work either individually or in groups, but I'd encourage you to work in groups if you'd like some help to bounce some ideas off each other. I think it's working really well. So if you are in groups, do that. Otherwise, any questions before we move on? Great. In which case, have fun with that. We'll rejoin at 4:10, and we'll go over the solution for that, and then I'll guide you to some further reading. Okay, see you in 30 minutes.